All right, this is lesson 8.5, evaluating published data. The essential standard. After reading a verbal description of a study, I can assess whether the results of the study, the claim that they're making, is warranted or misleading. And I can assess if graphical display of data is misleading. So when reading published reports or when viewing the results of studies, you must very carefully assess the claims that are being made. Organizations and people sometimes present information that is misleading or unsupported by the data. There are a lot of marketing tricks that are designed to mislead you. If the studies are not carefully designed, bias can be introduced, and the results of the studies will not reflect the truth. Make sure you assess the following. So we're going to assess the following things. First, was a random sample taken? If a random sample is not used, then the members of the sample may not reflect the population of interest. If the sample does not reflect the population of interest, then the results can be meaningless. So we want to make sure that they have taken a random sample of the population that they're making a prediction about. Sample size, this is also a trick they use. The larger the sample sizes, the less variability and the more likely to be closer to the truth, because there's variability with anything that we measure. So we want a large sample size to ensure that we have less variability and we can have a larger confidence in the data. Thus, the results from studies with large sample size are more convincing. We can have more confidence, right? We have confidence intervals. Smaller samples have more variability, and then we have less confidence and they're less convincing, okay? Survey implementation, all right? How we conduct a survey can impact the results. Two different ways. Questions can be poorly worded. This is very common in political surveys to make a desired response more likely. In addition, in-person surveys are problematic as people will sometimes be misleading or lie when asked certain questions. For example, if you were asked in person for a survey, do you use illegal drugs? You are more likely to not be honest if you do, because why would you want them to know that, right? So you would potentially have issues with an in-person survey. Anonymous surveys are more likely to represent the truth. Random assignment, okay? So subjects need to be randomly assigned a treatment, all right? We have to randomly assign treatments, not just pick which ones get the treatment based on what we want to have, let's say, happen in the experiment. We want to randomly assign it. So without random assignment, there could be some differences that are caused being observed differences, okay? So if we were going to randomly assign, like the migraine headache test, we didn't want to, let's say, pick just the men to take the placebo and the women to take the treatment. We want to have a random assignment of the treatment. All right, cause and effect. It is incredibly difficult to establish cause and effect without an experiment where treatment is imposed on the subjects. Okay, so if they are claiming a cause and effect, yet they did not do an experiment where they used proper techniques, how can they claim a cause and effect? Because there could be other factors that are causing the observed differences if it's not from an experiment. All right. So now let's go look at some actual studies and see if we can find the things that are wrong with the studies, if anything. Explain whether the conclusion presented in the following report is valid. So eating fruit lowers blood pressure. That's a claim that's made. The cafeteria at Midville Hospital offers a bowl of fresh fruit and other items for dessert. Researchers tracked 200 hospital employees who eat lunch at the cafeteria each day. They divided the employees into two groups, those who chose fruit for dessert and those who chose other items for dessert. At the end of the 6 months, the researchers measured the blood pressure of the employees and found that those in the groups that chose fruit had a lower average blood pressure than those who chose other desserts. And that is their claim or their data to show that eating fruit lowers blood pressure. So first off, they're making that claim about everyone, and they only tracked people at Midville Hospital. So there is no random sample of all people. Okay, so for example, if for some reason the people at Midville Hospital differ, which they could, they work at a hospital, maybe they're more conscientious than someone who works at a fast food restaurant. Some way, this difference might be the reason for their observation. Okay, that's the first thing that we could maybe claim is potentially an issue with this study. There is no random assignment to the treatment. They didn't assign people to eat fruit and others not. They just observed. So there is no random assignment to the treatment. Okay, that's another one. There could be other factors that are causing the difference in observed blood pressure. For example, maybe the people that normally chose fruit are more likely to exercise, right? So that could be. So by not assigning randomly people to eat fruit and those to not eat fruit, you're basically studying those that are already choosing to eat fruit. And again, they could have other behaviors that cause their blood pressures in general to be lower. So there could be other factors that are causing differences in observed blood pressure. In addition, this is an observational study, not an actual experiment. And it is very difficult, if not impossible, to determine cause and effect on using an observational study. So since this is an observational study, we cannot determine cause and effect. All right, let's do another one. And evidently, this was actually a true study and data was presented as if this actually was true. So explain whether the conclusion presented in the following report is valid. Slim by chocolate. A team of German researchers have found that people on a low carb diet lost weight 10% faster if they ate a chocolate bar every day. Not only does chocolate accelerate weight loss, the study found, but it leads to a healthier cholesterol levels and overall increased well-being. In the study, 5 subjects were randomly assigned to eat a dark chocolate bar every day while eating a low carb diet, and 5 subjects were randomly assigned to just a low carb diet. At the end of the study, when the 18 different health measures that were being studied were analyzed, it was found that 3 of them, weight loss, cholesterol level, and well-being, surveyed results were all statistically significant. Okay, so the first thing that should stand out is a very low sample size. This was a very small study. So within any sample size, there's going to be variability. So how do we know that the data that they collected was not from random variability or from sample variability and we could have results that are just part of normal variability. We can't make a claim per se from that. So this was a very small study. There was only 5 people, and is much likelier to have more variability between groups because of the limited number of people. Of subjects that they studied. Okay. In addition to that, there's something else that was wrong or kind of misleading about this. At the end of the study, they had 18 different health measures that they were testing. And notice they only gave you data on 3 of them. Okay. That is an indication that they were trying to mislead you, because they probably didn't want to tell you what the other 15 data points said. They found the 3 that were positive and only shared them. And because of the small sample size, just the variability alone would potentially give you some positive results. So 18 measures were studied, but only 3 were reported on. Well, that should be an alarm. Were reported on. They were essentially looking, it appears they are intentionally trying to find something good to report. Okay. All right. Why don't you try one yourself and see if you can figure out some things that you thought maybe whether or not this study was good or not. Welcome back. The study is titled "Cell Phones Not a Distraction for Most American Students in Class." A survey asked 450 students at Madison High School during lunch how often their cell phone is a distraction in class. Students were told by the person conducting the study that their cell phone should be considered a distraction if they used it or thought about it that morning during class time. Of the 450 students interviewed, 409 chose almost never, 30 chose sometimes, and 11 chose all the time. First off, the claim is made about most American students. The students that were asked were only at Madison High School. So we didn't take a sample, a random sample of American students. So there is no random sample of all American high school, of all American students, we'll say. Obviously, depending on what school you're at, you can have different cultures, different environments. If we wanted to know something about most American students, we would need to do a random sample of students, definitely at more than one school. Okay. It is possible that the students at Madison High School are differ than others. So it is possible that Madison High School students differ in some way. You could just think about our schools in our area. Some high schools, you know, have unique characteristics and differ than others. Okay. All right. The other thing that should maybe stand out is the students, although maybe not quite as clear, they were asked in person. And if they were asked in person to tell them whether or not they used their phone that morning, they might have felt pressure to answer no, they didn't. So since students were asked in person, they may have felt pressure to respond in a particular way. All right. The other thing I thought of when I was reading this is if they knew they were being surveyed about cell phones, they're going to obviously maybe say, no, I never did, because if the survey results were negative, maybe all of a sudden they had some new policy about phones at the school. So as opposed to anonymously being monitored. So anyway, let's see. They also asked about in the morning. Okay, this was an interesting observation Mr. Sadowski brought up, is if in general, we tend to be, not everyone, but safe to assume that some of us are more focused in the morning, and we tend to in the afternoon maybe start to become less focused, and maybe that's when we have more inclination to play on our phones. So we were only asked about morning. So students were asked only about the morning, about morning distraction. Maybe distractions more in the afternoon. Maybe students are distracted in the afternoon. And that's a real possibility. Who wants a math class, 8th period, right? Okay, let's move on. Now let's talk about graphs. Charts and graphs can also be misleading. Be careful to analyze the information presented in the charts so that incorrect conclusions are not made. There are very sneaky marketers out there that make graphs and charts make you believe what they want you to believe. Here's some things to look for. Scales. This is something they do quite often. Carefully examine scales. Scales can be used to magnify differences that are not significant. Okay, I'll show. There's going to be some examples of that. Histograms. They can also have issues. Okay, what's going on here? All right, histograms. This are the intervals that they select. The bars are the intervals the same, because if they're not, they can also be misleading. Okay, bar charts. Are the groupings logical or are they misleading? An agenda, think about who's presenting the data. Do they have a reason to create a misleading graph? Okay, they may have an agenda and they may have a personal bias, all right? All right, so for example, let's look at one. Is the data being presented misleading in any way? So here's A, we have a situation that says it claims DirecTV stops the competition. 95% of your favorite HD channels as opposed to Dish is 81 and cable is 56. And so what they have done here to mislead you is they have used area. Okay, so 95 is not a substantial amount more than 81 or 56, but we'll look at what they have done with the area of 95. 95, even if I were to double this 56 area, it would still not be as much area as what they gave for the 95 channels. So they have misled you by making the area of DirecTV much larger. So the advertisement is using area to be misleading. Visually, a 95 looks huge compared to the 56. So 95 channels is given much more area. Then would be proportional to the number of channels. Published by people who are wanting to promote DirecTV. All right, what about this graph? So this has to do with the percentage of victories of a baseball team, the New York Yankees and the Boston Red Sox. And we see that we have the New York Yankees has 53% and the Boston Red Sox has 42%. But what have they done? Well, they have started the scale at 0.4, and they have that makes this bar looks much larger than 0.42. If they would have started the scale at 0, we would have had something that, you know, if this is 0.5 and this is 0.4 and this is 0.3, 0.2, then those Boston Red Sox, this would have been New York, and Boston Red Sox would have been something that looked like that, and all of a sudden there is not a substantial difference visually between the two. Okay, so they have used scale in this situation. So since the y-axis started at 0.4, it magnifies the difference of numbers above the 0.4 level. 0.53 is not more than 5 times better than 0.24 percentages of victories, which is, you know, if you look at this, they're kind of indicating that it's substantially more. So 0.53 is not 5x better than 0.424 per, okay, of victories. All right, here's some relevant data. See if I can do a good job of explaining this. New cases in California versus rest of the country. The next two are about COVID. And I believe this came out of the LA Times. And this is incredibly misleading. So here is the, so here's the graph. And it says new cases in California versus the rest of the country. So California is the dark green or teal, and the rest of the country is in the light teal. So while California, America's most populous state, has the nation's top cases case count, it ranks much lower after adjusting for population. Home to 12% of the country's population, thus far, it has accounted for roughly 11% of the cases. So this graph is not actually population adjusted. So what it's saying is right about here, you can look at this. This is approximately 50,000 new cases. Right? And we're saying it's home to 12% of the population. So we would have to multiply 50,000 by approximately 8 to kind of compare it to the rest of the country, okay? And if you did that, you would get something approximately 400,000, right? And so if you compare 400,000 to 200,000, 250,000, or they're approximately less than 250,000 new cases, we were in this situation much worse than the rest of the country at that time. So this was a very misleading graph. So this, how we would say this is, this graph is not population adjusted. As a result, it appears California is always doing very good. But in reality, there are times when California has as a percent of residents a much worse case count. And you could imagine that there's probably a lot of reasons why they would want, depending if it's political, them to not look bad, right? All right, D, try one yourself. Let's take a look at this one. This has actually been published by the LA Times. COVID-19 in California. This is the percentage of deaths by age. So how about you take a look at that and see if you see anything that stands out. All right, welcome back. In this situation, this is again extremely misleading. And again, these width of our bars, this has a width of about 5 years. This has a width of about 5 years. This has a width of about 5 years. And let's look at this little width over here. This is 17 years. So essentially, in order to compare, you would need to take all these bars, which is 15 years of age spread, and add those bars together and be able to compare it to that one bar. Okay, so the bar widths are trying potentially maybe to scare you. I don't know what the motivation is, but the situation is that the risk for older population is substantially greater than, let's say, the younger population. And this bar width here has been, I'm not sure what the motivation is, but this is very misleading. So the bar width are still not uniform. Oh, I'm sorry, that's the second graph. Bars are not equal. In width. And it makes it appear the COVID-19 is dangerous. It's very dangerous for all people. And you could maybe even start as low as 35. All people aged 35 and up. Okay. Now they updated this graph. Maybe there were some complaints. And here is the new updated. And this time they have included in the light shaded gray the percentage of population. So you can see that there is a much larger percent of population that is in this age bracket 18 to 34, because once again, that is a 17-year span. Okay, so notice how much larger the dark value is above the percentage of the people that were in the population of 70 to 74. Okay, so it is it's a better graph. It's still misleading because they haven't adjusted their bar width. So again, this is 15 years of spread, and this is a 17-year spread. And if I were to take these little grays and add them together, I still don't get to the total number of people, percentage of population that is within that 18 to 34. So they're again, it's misleading. It's better, but it's not maybe the best way to present the data. They're still not uniform. But at least you now get some population information. Okay. All right, let's look at one. Let's try one that's, let's see if you can kind of see what you think about this one. Red Oak Cafe star ratings. Just try one yourself. What do you think about this particular set of data? Okay, well, anything that you see. So notice what they've done. They have combined the 3 to 5 star ratings together, and that can be very misleading. So for example, what if this was all my 3s and this was my 4s and this was my 5s? That would potentially not make you feel as good about it. So combining 3, 4, and 5 star bars together makes it appear that the cafe has a lot of high ratings. Okay, so I hope you find the lesson interesting. There's a lot of misleading data out there. We get fed it on a regular basis through many different resources. Hopefully you have learned some things about how to be skeptical. That's the first thing, to study it. Don't just assume it's accurate. So have a great day. I'll see you in the next lesson.